10 misconceptions about modern Earth. People have been curious about Earth ever since Apollo 8 revealed a large blue marble rising above the lunar horizon. Scientists now know a lot more, but not every detail is available to the public. This means that what we hear isn't exactly what they're trying to say, but it's close enough that everyone completely misunderstands each other. 10. Mount Everest is moving sideways rather than up. The Indian subcontinent decided 50 million years ago that it didn't like the neighborhood south of the equator and moved north. It eventually slammed into Asia, raising the Himalayan mountain range, including Mount Everest. Everest is now the world's tallest mountain above sea level, standing at nearly 9 kilometers, 5.6 miles. Since the India-Asia collision is still ongoing, isn't it still rising? Scientists who have meticulously measured the mountain's height say this is incorrect. In 1995, Giorgio Peretti, a professor at the University of Trieste, discovered that Mount Everest is not actually rising at a meaningful rate. Better instruments have simply improved the accuracy of height measurements. Instead, the ongoing continental collision between India and Asia is pushing Everest northeast at a rate of 42 millimeters, 1.6 in, per year, according to Peretti. As a result, on your next Everest expedition, you will ascend roughly the same number of meters as Sir Edmund Hillary and Tenzing Norgay did in 1953. You will, however, be nearly 3 meters, 10 feet, to the north-northeast of where they achieved their record-breaking success. 9. Mauna Loa is the tallest mountain in the world. Speaking of Mt. Everest, it is not the tallest mountain on the planet. Mauna Loa, which translates to Long Mountain, is located on the Hawaiian island of Oahu. It doesn't appear to be as tall as Everest because it is mostly submerged and all we can see are their summits. Mauna Kea is 10.2 kilometers, 6.3 miles, tall from summit to base, making it much taller than Everest. Furthermore, Mauna Loa adds weight to the game, which makes all the difference. Mauna Loa encompasses roughly half of the Hawaiian island. Volcanoes such as Mauna Loa are referred to as shields because they are wide and have a low profile, much like a shield. They are formed when a volcano erupts lava at a rapid rate. Because molten rock pours from Mauna Loa so quickly, it has little time to do anything but pile up and cool. Mauna Loa has been erupting frequently for up to 1 million years and is still very active. With 1 million years of output, you get a lot of volcano, 80,000 cubic kilometers, 50,000 cubic miles. The Pacific Ocean is about 5 kilometers, 3 miles, deep where Mauna Loa first began erupting. The massive lava flow eventually raised the mountain 4.17 kilometers, 2.59 miles, above sea level. But wait, there's more. The massive weight of Mauna Loa has pushed the seafloor down another 8 kilometers, 5 miles. Taking that into account, this volcano is over 17 kilometers, 10.5 miles, tall, making it by far the tallest mountain on the planet. 8. Tornadoes cannot be seen. Everyone runs for cover when they see a tornado approaching, but how do we see the tornado in the first place? After all, air is imperceptible. Technically, what we see is a condensation cloud composed of water droplets and, on occasion, dirt and debris. It forms inside the actual tornado's invisible funnel of moving air. Tornadoes are typically formed by supercell thunderstorms, which have a rotating updraft. Nobody knows what causes the funnel to move downward from the supercell to the ground. It could be related to temperature variations along the edge of a nearby downdraft. Water vapor usually condenses inside the rotating funnel of air as it descends from the supercell, but tornadoes can and do begin wreaking havoc on the ground before the funnel has formed completely. For example, here's a tornado on the ground with a partially condensed funnel cloud. If you didn't see the debris and this was hitting your way, you might just stand there and watch the natural drama. This could be a fatal error. 7 tons of clouds. Few things are more beautiful than fluffy white clouds floating in a blue sky. We often think of such clouds as being no more than fog. Clouds, on the other hand, are quite substantial. The average cumulus cloud, which is composed of water droplets, weighs 550 metric tons, 500 tons. Because the atmosphere around it is so dense, such a massive behemoth can float. It's easy to forget that the cumulus cloud and we both exist near the bottom of the atmosphere. The weight of air molecules is approximately 1 kilogram, 2.2 pounds, per square centimeter, or 17.2 metric tons, 15.5 tons. That's a lot of force against a 168 centimeter, 5 feet 6 inches, 63.5 kilogram, 140 pound human. This weight, however, does not crush us, because it exerts equal pressure on both the inside and outside of our bodies. Furthermore, air, like water, is a fluid. This enables the Archimedes principle to be applied. The cloud's buoyant force is equal to the weight of the air it displaces. That multi-ton cloud floats in the air this close to the Earth's surface for the same reason that a cruise ship floats on water. 6. There are magnetic tornadoes on Earth. NASA scientists were taken aback when their messenger mission to Mercury discovered twisting tornadoes 800 kilometers, 500 miles, wide in the planet's magnetic field. These flux transfer events, also known as plasmoids, occur when Mercury's magnetic field collides with that of the Sun. Scientists believe that these two factors are to blame for Mercury's thin atmosphere. The solar wind, plasma blown outward by the Sun, is funneled down onto Mercury's surface, where its electrically charged particles release gases trapped in rocks. For a long time, scientists have known that the magnetic fields of the Earth and the Sun are linked. After all, this is what causes auroras. What they didn't realize until the Mercury discovery was how turbulent the connection is. Don't worry, though, because Earth experiences these magnetic events as well. We are not all going to perish. Despite the fact that a new event occurs every 8 minutes, our planet's atmosphere is thick enough to protect us from a flood of lethal radiation. 5 rocks are inhabited. Have you ever felt like you weren't alone in the desert or a deep cave? You most likely weren't. The rocks may not have ears or eyes, but they are home to tiny life forms known as endoliths. Endoliths are extremophiles, which means they thrive in harsh environments. They were discovered nearly 3 kilometers, 2 miles, underground in bedrock. Most of them survive on water and food that falls through cracks, but some eat rock and excrete acid that aids in the digestion of more stony snacks. When it comes to how far down into the Earth life can go, temperature is the limiting factor. Heat radiates from the planet's core, and the temperature of the rock beneath the surface can reach 125 degrees Celsius, 257 degrees Fahrenheit. Although no researchers have been able to penetrate that deep into the Earth, studies on extremophiles and hot springs show that they have difficulty reproducing at that temperature. So 5 kilometers, 3 miles, down could be the limit. These organisms are so small that if they are packed all the way down into the Earth's crust, the majority of the planet's biomass may be underground. Astrobiologists have been conducting underground experiments in planetary exploration spacecraft to look for extraterrestrial life that may have settled beneath our feet since the discovery of endoliths. 4. Switzerland rises and falls almost 25 centimeters, 10 in, per day. The Earth is not only nutritious to some forms of life, but it's also a little pliable. That is why the Mauna Loa volcano can depress the Pacific seafloor so significantly. Because of this elasticity, the moon and sun can affect both land and sea, though not to the same extent. There are no shores to measure the ebb and flow. Large swaths of the Earth's surface rise and fall slowly and almost imperceptibly. But that's only on plains or anywhere there isn't a massive volcano or mountain range to hold it down, right? Not at all. Even the Alps are insignificant in comparison to the sun and moon. In fact, precise measurements have revealed that the entire country of Switzerland rises and falls daily on an earth tide of about 25 centimeters, 10 in. It only matters if you're building something delicate, like a particle accelerator, because the country's shift is relative to the Earth's low tide point, which is 10,000 kilometers, 6,200 miles, away. 3 cyclones can dance. Tornadoes are sometimes referred to as cyclones, but cyclones are actually low-pressure systems with winds that spiral counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. A cyclone can be a hurricane or any other low-pressure system with the proper wind direction. Sakuhei Fujiwara, a Japanese meteorologist, discovered that when 2 cyclones get close enough together, they will orbit, or dance, around a common center. This Fujiwara effect occurs only when their strengths are roughly equal. Otherwise, the smaller cyclone will be absorbed by the larger one. In 2012, the world witnessed a very costly and destructive example of this. Most hurricanes that form in the Caribbean and Atlantic Oceans become entangled in westerly winds that blow them away from North America. Up to a point, Hurricane Sandy accomplished this. Because of an upper-level low-pressure system nearby, it abruptly reversed course and returned to the United States and Canada as Superstorm Sandy. Its spinning winds began to move in the same direction, and the Fujiwara effect began to take effect, bringing the former Caribbean hurricane back to land. However, due to Sandy's size, the two storms merged right at landfall, the worst possible location. Two massive earthquakes occur slowly. When rocks move along a fault, an earthquake occurs. The fault line could be a local break, in which case the shaking will most likely be local, or it could be a major boundary between two tectonic plates. Plate movements accumulate enormous amounts of energy in the rocks along such a boundary, and when it slips, the consequences can be disastrous. Foreshocks are common in large earthquakes, but scientists were surprised to discover that rocks can creep past each other without causing any shaking. They discovered this after deploying extremely sensitive equipment along California's San Andreas Fault, where the Pacific and North American plates are slipping past each other, and New Zealand's Alpine Fault, where the Pacific plate is sliding against the Australian continental plate. The Alpine Fault has been the site of several major earthquakes in the past, but its central section has been unusually quiet. Scientists began closely monitoring it, suspecting that section was storing potentially apocalyptic amounts of energy. Instead, they discovered seismic tremors, which are a series of small, creeping earthquakes that are deeper than typical quakes and can last up to 30 minutes each. Something similar has been discovered along the San Andreas Fault. Scientists are baffled as to what the tremor is up to. It could be storing stress for a future earthquake, or it could be releasing some of that pent-up energy and lessening the magnitude of the next time the fault zone slips. The next supervolcano eruption probably won't be at Yellowstone. Geysers, hot springs, and boiling mud pots abound in Yellowstone Park. However, at the turn of the 21st century, geologists realized that there are such things as supervolcanoes, and Yellowstone Volcano is Exhibit A. Everyone has been wondering when it will explode since then. That, however, is unlikely to occur at any time relevant to human civilization. Recent research has revealed that, while there is a lot of magma down there, it isn't eruptible. Because there has never been a megacaldera eruption in recorded history, no one knows what to look for. Before the main event, there could be a slew of earthquakes and other natural disasters. Ordinary volcanoes, on the other hand, occasionally erupt unexpectedly. Supervolcanoes could do the same. One intriguing candidate is Chile's Laguna del Mal, though the volcano is not currently erupting and exhibits no threatening behavior. It has simply been inflating at a rate of 24 to 28 centimeters, September 5th, 11 in, per year for no apparent reason. Laguna del Mal, located on the Argentine border, is roughly the size of California's Long Valley caldera. Over the last 20,000 years, it has had at least 36 small-scale eruptions. Researchers believe they have found enough eruptible magma to cause a VEI-6 eruption, not a supereruption, about the size of Pinatubo in 1991, but they are unsure if that is all there is. That's for now. We appreciate you for being here. View more our channel videos.